where there's lots of shielding, the enterprise could use that same frequency. And then if I'm further out in the suburbs, individuals could use that as their home network. It's not going to be exclusive. A long time ago, the principle was use it or share it. Now, this looks a lot like unlicensed. One of the things that's introduced in this band is a second tier. You can go to auction and buy protection. Protection means you are guaranteed not to be interfered with, but it doesn't give you the right to exclude. So today when I go to Spectrum, we think about it as having foreclosure value. That is, it forecloses the right of someone else to come in and compete. There is no foreclosure in this band. You can go buy Spectrum, and if you don't use it, you have donated it to everybody else for them to use, and thank you for your donation. So we achieved the goal of Spectrum licensing, which was to protect people from interference, which is what we tried to do, but without the onerous impact of giving people the right to exclude other people from what is really a public asset. To do all this, it's fairly complex to protect potentially millions of devices that get protection in the Navy and all. So it also introduces a cloud-based microtransaction system called the Spectrum Access System that kind of hides all this complexity from devices. So if you think about what we do today, with a typical device goes on a network and it goes and gets an IP address, same kind of model. Instead of going to a DHCP server, you're going to go on that network and go get a frequency from the SAS that you can use that's deconflicted from all of the other guys on the band. But it's a logical extension of what we're doing today. Particularly close to my heart, I'm Google's program manager for the SAS. Competition. Today, you know, if you like the economic theory coast, well, Spectrum should be auctioned to get the highest and best use. But we're also all technologists, and highest and best use changes over time. TV broadcast, radio broadcast, wireless telegraphy, all of those have changed. So this band has continual competition. If you get one of these licenses for protection, after a couple of years it's not renewable anymore, you have to go back to the auction. My SAS has to compete with other SAS providers so that you as users get the best deal. So no one has essentially a forever license to a piece of Spectrum or to a line of business. Keeps refreshing what's the highest and best use. Other big changes. Today, you could almost think we have an unlicensed world, relatively constraining on power, what you can do. We have the licensed world, high power. Both these priority licensees and the kind of unlicensed equivalent, general access, have exactly the same rights. Now, if you're in this room, what that means is that these two markets are technically equivalent. Whether 10 million people are buying these as a home access point, or carriers are buying 10,000 of them, it's the exact same equipment and the same rules. So, you know, if you are in the cell business today, you can only look at Wi-Fi, who is selling hundreds of millions of parts with some degree of envy. They can look at you with some degree of envy that you can charge $5,000 and $10,000 a box. Well, those two worlds kind of merge here. You know, in PCAST, we felt the opportunity here was to provide carrier-grade technology to people at the kind of volume and thus cost points of unlicensed. And then because this would become really popular, because this is such a great deal, there's a guarantee that at least 50% of the spectrum is always available for unlicensed. So if you go deploy a network, you get it at auction, someone comes in with better stuff. You don't get kicked out, you don't lose your license. There's a 50% of the spectrum that's always available to you. You can always know it's there, provides certainty. Really, each one of these principles is fundamentally radical. Now, what the band looks like, everybody defers to this Navy carrier. The good news is we can't afford to buy many of them. So there's, I believe, at last count, 27 of these, most of which are off doing whatever we do overseas. This intermediate tier pays for protection. Essentially, they care about quality of service. They could be carrier offload enterprises, MVNOs, wholesalers of bandwidth. And then we have a tertiary. You can think of this as traditional unlicensed users. Now, if you had drawn this chart 2 years ago, everybody said carriers are here and non-carriers are here. But people get smart. Some enterprises that are very large might choose to actually get protection if they have census tract type of geography. And carriers are starting to think, there's 150 megahertz. There's no one else in the band. Why would I pay for anything? I can go use it free. So this band creates fungibility between these two. These are really the same communities. All of them go through a process of my SAS spectrum occupancy. Devices in either tier come on and register. If you are a secondary guy, we might have to move you because a Navy radar came in. It's not bad news. It takes 1 out of 15 channels. If you are a tertiary user, I might have to move you because you were in PAL spectrum and one of these guys keep fired up and we have to move you out of the way. But again, not really bad news because half the spectrum we reserve to move you to. So how does SAS work is that devices register, we deconflict with federal users, we deconflict with other protected assets. Also, we have approximately 6,000 satellite receivers. We have the PALs, which could be about 5 million, about 65,000 WISP sectors, which are grandfathered for about another 4 years. Higher tier users bump lower tier users, decide how much is that spectrum worth to you, and then we guarantee you don't get kicked out. I think we thought of everything. So, think about the SAS, think about how it solves some of the problems we've always had with spectrum management. We now have a way to offer someone the use of the spectrum, whether you're a federal incumbent or you're a PAL. You use the spectrum as if you're exclusive. If you deploy somewhere, anyone who might interfere with you gets moved out of the way. So from your point of view, this is exclusive. One of the big concerns in the past over spectrum has been aggregation effects. Due to the cloud, we can now deal with that. So we deal with 10 to the 14th interactions in the fully deployed system. So that if it's a satellite dish and no one person interferes, but 1,000 people might, we keep accumulating that and doing it mission control. We worry about both the in-channel and the device-specific out-of-band. Device-specific, because we want to give people in industry an opportunity to do better. You know, if all you have to meet is a minimum regulatory threshold, there's no incentive to do more. In this framework, there is. If you have better out-of-band emissions, we can put you into more places. You get more benefit. Just as a note, we deal with antenna directionality and nulling. And then in the case of LTE, there's a lot of technology-specific optimizations that we don't want the FCC to deal with, timing, resource block allocations. Those can also be passed to the SAS to coordinate. So what have we done? We fundamentally changed the economics of spectrum. Buying spectrum is no longer existential. If you want to be a carrier today or you want to do LTE, you have to buy spectrum. It isn't true now. You can go and register as either GAA or PAL and never have to pay a cent for spectrum. If it's really worth it, you're in Times Square in New York and there's lots and lots of people doing operations, you might want to buy it. If you're out in Kansas and you want to deploy an enterprise network, you probably don't have to pay for it at all. So your decision to buy changes. It's now based on what's the revenue from this box, what's the degree of congestion, are you tolerant of interference? Why pay thousands of dollars for spectrum to protect 10% of the throughput of a $500 box, and whether you can live with it? So we've created a whole new piece of gamesmanship, if you will, in wireless, to really think about spectrum strategies that are very, very local to the box. And this all changes. You don't get ownership for life like we do today, right, of renewal. It's going to continue to open. Every year you can rethink your spectrum strategy. Your boxes can tell you, gee, I'm getting so much traffic, I'm getting all this interference. Next year, buy me spectrum. So, why is 3 tiers? So the talk is about shared spectrum, but what we're really after is this 3 tiers. What does it do? It means that the same technology and equipment that you would sell into carrier deployments, into protected, are also used by traditionally unlicensed. We see that as really enabling. Personally, I would rather have 40 megahertz of carrier aggregated LTE in my basement than Wi-Fi 802.11ac. I like Q, I like the authentication, the security and all. Well, I become a customer for small cell and for small access points in this band. You don't have to get much of the Wi-Fi market to fundamentally change volume in small cell. You know, we're talking 1 or 2% here. Spectrum's no longer the partition between Wi-Fi and LTE. Wi-Fi can come into this band, but LTE equally. These two now merge, they can go to either market. People can come in, now let's think about your customers. I want to do wireless in New York City because I've got a lot of people who want to do Internet of Things around Times Square. Today, I'd have to wait 5 years for the next FCC auction. I'd have to wait then an average of 8.4 years to take control of the spectrum. I go deploy today. I can go put it out there. If I get interference, I can go buy a PAL next year. So there's a whole opportunity for new kind of entrants to come in and do wireless services without having to go through the 13-year delay it takes to get spectrum. If you lose an auction, you're not orphaned. you just become GAA. The value of the equipment's maintained, so it's not at risk. And you've got shorter term licenses, so this is going to become a much more dynamic wireless environment, at least in this one band. What was highest and best use 3 years ago is unlikely to be the highest and best use today. So new kind of ecosystems. So this is sort of the my marketing pitch to you. What's going to come into this market? Well, first let's think about enterprise. Enterprise spent a lot of money to do Wi-Fi deployments today. So if you are enterprise and you take a look now, I can go and deploy LTE inside. I can put my desk phones on it. I can take my Wi-Fi over. If you think about it, this is inherently neutral host. Someone said, I think in an earlier panel, that neutral host was the best solution. Well, I think it has a competitor now, because one of the things we put in the regulations was that if people build devices in this band, they have to cover the entire band. So if a carrier puts 3.5 into a handset, they have to cover the entire band. That means that handset can also work into anyone else who supports band 42, 43. So the enterprise. So that iPhone, I'll be Android, I'll be nice to Apple today. That iPhone I bought because the carrier supported 3.5 offload, would also work into the enterprise on 3.5. So DAS, Wi-Fi, lots of things that are very expensive in enterprise become practical. And really, if you think about the LTE ecosystem, was really built to support these kind of applications. Second one's third-party wireless. If I'm deploying this, there's an opportunity here for new entrants to think about becoming wireless providers. We know that for carriers, getting backhaul, getting power, and getting access is really expensive. A lot of enterprise building owners, shopping mall owners already have all of those. But they have an opportunity to come into this and become suppliers. And then lastly, as the price point drops down, this becomes a consumer technology. Certainly just the security and the seamless operation of LTE alone. Now, it might be strange to think about personal devices that are dependent on EPC and on the cloud, but if you notice, like Google OnHub is a cloud-managed Wi-Fi service, and it's been very successful or sold out. So people are willing to have central management of their home assets. The value's there. So there are a lot of reasons why these non-carriers would adopt LTE. The security authentication, I think, alone is an argument. We have the automated management of coexistence. Wi-Fi wasn't built with coexistence. No one sells a Wi-Fi box based on how well it performs with 50 other SSIDs right around it. That's the market LTE was built for. The revenue from sellback, alternatives to building DAS, higher bandwidth density, assured QoS, and then there's probably more I haven't thought of. Whoever figures that out, that's part of the market. So, some things I think people ought to be thinking about. They're either challenges or opportunities. As we move into non-carrier types of deployments, we're moving away from dedicated dark fiber, running over flexible backhaul. Very clearly, the Wi-Fi model of deployment is a very successful model. A lot of people in this room probably on Wi-Fi. It works well. It would be good to bring LTE to operate over that deployment model. We might lose something like timing. We have to rethink how valuable these things are. The cost comes down. We have to solve the problem. My own belief is cost is more a function of volume than complexity. Wi-Fi 802.11 AC 1.9 is more complex than LTE, but it has so much volume it's very cheap. There's an opportunity here to bring volume to LTE products. And I think the scalable control, I'm not going to go buy an EPC and put it in my basement. So scalable EPC and MS services become key to this. But these are solvable problems, and the person who solves them, I think, has an incredible new marketplace. Nothing in this area works without standards. I want to put a plug in. I am a co-chair of the Wireless Innovation Spectrum Sharing Committee. We are working to establish standards for this, standards that would make all SASs interoperable with all devices, so we don't get little stovepipes of vendor and SAS supplier. We have all 4 US carriers, Nokia, Alcatel, Lucent, Ericsson, Qualcomm, Huawei, I think one in the room, Intel, Google, Federated Ruckus. Pretty much all of the community that's involved are participating in this. If you look in the R&O from the FCC, the rulemaking, there's 8 places where it calls out multi-stakeholder group. So they deferred a lot of the implementation issues to us. We're a very active group, 4 bi-weekly meetings, and we're making steady progress. We're looking, I think, by the end of first quarter of next year to have all of our standards at least in draft form. So, if you follow spectrum, if you have any geekdom in spectrum policy, it's been 10 years since we started dynamic spectrum sharing in academia. I was at DARPA and started the programs there. It took 10 years from that to President Obama signing it out and saying it's the policy of the US government. That's not too bad. Academics did this for you guys. Now our challenge, I think, is to move this, and 10 years is pretty good for a major change. So, we'll take credit. The goal now is to make our European friends think about it as the next logical step. When we started this, it was all ASA, LSA. Now it's ASA, LSA, maybe as a stepping stone to 3-tier. So I think this, 5 years from now, this is a global market, not a US one. Maybe it's not just yesterday's LTE. There's fundamental architecture changes to really make this work. And the companies that think about this a little fresh way, I think, have a big advantage. And there's a lot of real challenges in here to differentiate. LTE itself is very much of a commodity, standards-based. But how do we democratize LTE? How do we go from just 4 carriers building and deploying it to potentially tens of thousands of organizations deploying LTE? Federating it, how do we make use of those interoperabilities across management domains that don't share EPCs? New topologies where we're going to run over intranets. We're going to form LANs rather than just wide area networks. New spectrum auctions. In fact, we're having to make these economic decisions. And then we have introduced a new command layer. So we've offered a lot of opportunity for people to innovate and create some really innovative solutions, and taking a commodity air interface and really thinking about different ways of applying it to these markets. So thank you very much. I will pass it on to my notees. I think we'll do questions at the end.
Thank you.
Oh my God.
That's okay. That's all right. Well, Preston, thanks very much for setting us up. They had 10 years of work on getting the spectrum available, and now we're going to talk about, okay, how can we really make this commercially viable? So all those little bullets that you had there, now let's see what it actually takes to do. So we'll talk a little bit about commercial enablement here, in particular from an outdoor and indoor use case. So you heard about the particular spectrum, and here's where we're at. We're sitting in that 3550 to 3700. This is all the activity that's taking place. This is the spectrum that will become available in the 2016 timeframe. But if you kind of take a look, we're not done yet, right? So there's already work that's taking place within the Technical Advisory Board, looking to continue to go ahead and open up that particular spectrum. So what's actually being laid down here as the groundwork for SAS just continues to carry forward. So in that, though, we mentioned some of the ERPs that Preston mentioned, and this kind of gives you an idea. The devices get actually categorized. So just to let you know, a small cell now has a citizen broadband service device, okay? But you might hear me use the word small cell because that's where it actually is contained. Different flavors. Depending on where they're actually going to be deployed, that A tends to be in the cluster area. You have some non-rural and rural type deployments. If you notice, the ERP is actually done, specified along with the conductive power, which in some of these outdoor cases relatively appears to be low power. So things to be taken into consideration when building the particular small cell. These particular powers are allocated on a 10 megahertz basis.
You should mention we have a reconsideration.
Yes, yes, you're actually, so I think I kind of mentioned that someplace there, so subject to change, right? So continued work to go ahead and...
Approximately 9 to 10 dB more.
9 to 10 dB. So it's a lot of confidence right here, don't you notice that? So once again, so here's the spectrum, here's the power level. What does that equate to? That equates to small cell deployments, okay? And where are these small cells going to be deployed in this particular room, this particular forum? In all the particular venues that we're already targeting small cells. The stadium's the venue, underlay deployments, conference centers. I don't have residentials there, shopping malls, airports. So if you take a look at it, both outdoor units and indoor units will be the ones leveraging the 3.5 spectrum. So once again, I feel like I'm speaking to the choir here, but, or is it singing? But in any case, when you look at small cells, we do have the particular challenges that we need to go ahead and deal with. 3.5 doesn't alleviate any of those problems. It just means that we have to go ahead and focus on those particular challenges. But us as a industry and as a community, we've actually moved forward. So the particular small cell deployment solutions that have already been identified just now get carried over into the 3.5 spectrum. So we brought up the backhaul, the ability to go ahead and deploy backhaul in the context of line-of-sight, non-line-of-sight wireless backhaul. But there is a delay tolerantness that we need to look towards. This isn't, we don't see these being deployed at, let's say, remote radio heads with CPRI with high data rates. They'll need to operate over those IP high latency networks, maybe approaching 5 milliseconds worth of latency. And even some of the concepts we've been seeing develop, such as UE relay, all of those can actually be applied to what we're doing in the context of 3.5. From an RF performance perspective, one of the values that we have in LTE is the advanced interference mitigation features. Those carry on, especially in the context of the GAA space, where you're actually dealing with interference between small cells that'll continue to exist. There is one thing we got going for us, is that in the context of 3.5, we're dealing with an F1, F2 configuration. So the frequency being used by the macro and the frequency being used by the small cell are different. So once you actually accomplish that, it eliminates a lot of those interference mitigation problems that would exist. A much more cleaner and easier deployment in the context of a multi-vendor deployment. The continued need to drive towards very intuitive planning with adaptation. As we said, if we go ahead and take a look at 3.5 and the expected explosion of the amount of small cells, being able to live in the context of still planning these types of deployments needs to move away. We need to move more to an intuitive, but intuitive gets you day one. What gets you day two? It's the adaptation part. So you want to make sure that these particular systems that we're designing are capable of dealing with day two, not just day one. The deployment options, pretty straightforward. Form factor, stealth designs still will be predominant there. This is an example of taking a look in a different innovative way, looking at how to go ahead and deploy small cells. In this particular context, what you're actually doing is return on investment, being able to take a particular site, determining what value it might bring in the context of backhaul, power, site location, and then applying some of the elements of how much does it bring in the context of performance. Using that to create an index to better allow you to figure out, well, where is the best place to place the particular small cell. So concepts key to move on forward. Preston, you kind of mentioned this move towards SON, no-touch operation. Once again, all meant to drive towards this mass deployment. And once again, I do understand in a small cell, this understanding of driving PoE is pretty straightforward. You really want it in an indoor environment to leverage the CAT cables that actually exist. Use that to go ahead and drive power. But you also want to go ahead and see if there's opportunities for you to actually leverage and use the network that's currently in place instead of putting in a new one. So like I said, I believe we're well on the way in the context of small cell. Now, if we take a look and say, well, we're doing LTE, and LTE seemed pretty straightforward within that presentation, but the reality is, if you take a look at some basic functionality that needs to be